Hello, this is Lazarus at telecomTech, where telecom and networking technologies are simply explained. Today we'll be simply explaining Layer 2 VPNs over an MPLS infrastructure. If you haven't already done so, don't forget to subscribe and enable notifications. And don't forget to like this video if you like this video. There's much more to come, so this way you can stay tuned. MPLS stands for Multi-Protocol Label Switching. The multi-protocol part means that MPLS is able to encapsulate virtually any type of network protocol. This includes Layer 2 protocols. And this is actually quite useful, especially if a customer requires the ISP to deliver Layer 2 connectivity between its remote sites. This capability in general is referred to as Layer 2 VPNs over MPLS. In simple terms, the MPLS infrastructure of the ISP plays the role of a switch. If we assume that the Layer 2 protocol we want to transport over the MPLS network is Ethernet, you can think of it like this. The whole of the MPLS infrastructure is simply one large switch, where the various customer networks are connected to ports that are configured on the same VLAN. The result is that hosts on the same subnet at this location and at this location will be able to communicate with each other on the same subnet. The MPLS infrastructure simply takes the frame and encapsulates it, and using various internal mechanisms ensures that the frame reaches the intended destination based on the destination MAC address, just like it would if both these hosts were connected to the same physical switch. As always, MPLS does not function alone. It is simply used for the label pushing, swapping, and popping in the core. The technologies that work with MPLS to make Layer 2 VPNs possible are applied on the PE routers only. There are various technologies that can do this, and some support multiple Layer 2 protocols, while others are created to carry specific protocols only. I'll name a few of the most popular such technologies and describe them further here. Among the most prominent is Virtual Private LAN Service, or VPLS. VPLS provides a multi-point Layer 2 VPN over MPLS, allowing geographically dispersed sites to connect as if they are on the same Ethernet VLAN. It supports full mesh connectivity among all sites within the VPN. This means that you can have multiple customers connected, and communication will take place directly between each customer site. VPLS is designed specifically for Ethernet, and although it doesn't strictly require it, MPLS is the most common transport technology used for VPLS implementations due to its scalability and traffic engineering capabilities. EVPN, or Ethernet VPN, is a newer and more flexible Layer 2 VPN technology that uses BGP as the control plane to advertise MAC addresses and reachability information. It supports both point-to-point and multi-point services and is often preferred for large-scale deployments because of its scalability, its support for MAC address mobility, as well as its efficient bandwidth utilization. Now, arguably the most common technology used in conjunction with MPLS to deploy Layer 2 VPNs is called AToM, which stands for Any Transport over MPLS. Now, unlike EVPN or VPLS, AToM is capable of transporting a variety of Layer 2 protocols, and not just Ethernet. This includes things like frame relay, ATM, PPP, and HDLC. AToM enables point-to-point Layer 2 connections, called pseudo-wires, by encapsulating Layer 2 frames in MPLS for transport across the network. Because such a link is point-to-point, it emulates a direct connection between the devices at the two customer sites, rather than emulating one large switch, as is the case with VPLS or EVPN. Now, other than these three, which are the most common, there are a whole series of other technologies that can be used to encapsulate Layer 2 protocols over MPLS. Now, each one has different capabilities and has different use cases, but I'll just mention them here in case you want to look them up in any detail. These include Ethernet over MPLS, or EoMPLS. Now, this is actually a specific type of AToM that encapsulates Ethernet frames over MPLS, allowing point-to-point Ethernet circuits across an MPLS network. Then there's HVPLS, which is hierarchical VPLS. This is an extension of VPLS that includes a hierarchical design to improve scalability by grouping customer sites and reducing the need for full mesh connections in larger networks. Then we have Virtual Private Wire Service, or VPWS. Now, this is another point-to-point Layer 2 VPN service, which is similar to AToM, and it's commonly used for creating Ethernet Private Lines, or EPLs, as well as Ethernet Virtual Private Lines, or EVPL services. Then there's Pseudo-Wire Emulation Edge-to-Edge, or PWE3. This is an IETF standard framework for emulating point-to-point Layer 2 services over a network like MPLS. Then we have Provider Backbone Bridging with EVPN, or PBB EVPN. This actually combines two technologies, Provider Backbone Bridging with EVPN, to offer scalable Layer 2 VPNs over MPLS, and this is especially useful for large-scale metro and carrier networks. Then we have TDM over MPLS, which is used for transporting time division multiplexing traffic for older circuit types like T1 and E1, or for SONET and SDH over MPLS. Now, this too uses pseudo-wire technology, allowing legacy voice and circuit-based services to be carried over MPLS. And finally, we have OTN over MPLS, which is Optical Transport Networks over MPLS. Now, OTN over MPLS enables the transport of optical data units, or ODUs, across an MPLS network, facilitating a Layer 2 service for optical networks. Now, all of these technologies fall into two categories, essentially the point-to-point and the multi-point technologies, as you can see them grouped here. Now, all of these fulfill a whole spectrum of different needs and capabilities for providing connectivity, covering a wide range of Layer 2 protocols and use cases over MPLS infrastructure. Now, these technologies don't only deliver connectivity, but also provide isolation of the traffic that belongs to different customers, ensuring L2 VPNs are deployed successfully within an MPLS infrastructure. Now, all of these technologies show how diverse and flexible MPLS is. It can carry any of these, and it can work with all these different types of protocols. In a future video, we'll be looking at the configuration of one of these particular Layer 2 VPN technologies, but I won't mention it here for now, but you can look out for that in a future video. I hope you found this video useful, and if you have, please click that thumbs up button. And if you have any questions or feedback, please feel free to leave a comment. I'm always happy to read your comments and to respond. And please subscribe to get updates to newly published videos. I'm Lazarus at telecomTech. I hope this has been helpful for you, and I'd like to thank you for watching.